Welcome to our Grade 8 Mathematics Reviewer. In this presentation, we will review important skills in statistics, algebra, polynomials, rational expressions and equations, sequences, and coordinate geometry. Pay close attention to the examples because we will use these skills to solve real-life mathematical problems. By the end of this reviewer, you should be able to calculate and interpret statistical data, translate real-life situations into algebraic expressions, manipulate polynomials and rational expressions, recognize patterns in sequences, and solve problems involving points, distance, and midpoint on the Cartesian coordinate plane. Measures of central tendency help us describe a set of data using one representative value. The three commonly used measures are the mean, median, and mode. Each one gives us a different way of identifying what is typical or central in a collection of numbers. To find the mean, first add all the values. Here, the sum is 50. There are 6 values, so we divide 50 by 6. The result is approximately 8.33. Therefore, the mean of the dataset is 8.33. To find the median, arrange the data from smallest to largest. Since there are 6 values, we have 2 middle values, 8 and 9. We add them and divide by 2. Therefore, the median is 8.5. The mode is the value that appears most frequently. In this data set, 10 appears twice, while the other values appear only once. Therefore, the mode is 10. Notice that both groups have the same mean of 80. However, the individual scores are distributed differently. Group B has a wider spread because it includes 60 and 100. This reminds us that the mean alone does not always tell the complete story about a dataset. Algebra allows us to represent real-life situations using symbols. We use a variable, such as x, to represent an unknown number. The key is to translate words carefully into mathematical expressions. Each notebook costs 25 pesos. If the student buys X notebooks, we multiply 25 by X. Therefore, the total cost is represented by 25X pesos. This is an example of using algebra to model a real-life situation. When adding or subtracting monomials, we can combine only like terms. Like terms have the same variable and the same exponent. We operate on the coefficients while keeping the common variable part unchanged. First, combine 12x and 7x to get 19x. Then, subtract 5x from 19x. This gives us 14x. So the simplified expression is 14x. When multiplying monomials, multiply the numerical coefficients. For the same base, add the exponents. 3 times 4 is 12, and 2 plus 3 is 5. Therefore, the answer is 12x to the 5th power. When dividing powers with the same base, subtract the exponent in the denominator from the exponent in the numerator. 5 minus 2 is 3. Therefore, the answer is 4x cubed. These are important laws of exponents. When multiplying like bases, add exponents. When dividing, subtract exponents. When raising a power to another power, multiply the exponents. Any non-zero number raised to 0 is 1, while a negative exponent means the reciprocal. Let us apply each exponent law. 3 plus 4 gives 7. 8 minus 3 gives 5. 2 multiplied by 3 gives 6. Any non-zero base raised to 0 equals 1. Finally, a negative exponent tells us to write the reciprocal. The distributive property tells us to multiply the term outside the parentheses by every term inside. 3x times 2x gives 6x squared, and 3x times 5 gives 15x. Therefore, the product is 6x squared plus 15x. When multiplying two binomials, each term in the first binomial must be multiplied by each term in the second. Using FOIL helps us remember the four products. After multiplying, combine the like terms, 5x and 3x, to get 8x. FOIL is a useful method for multiplying two binomials. F means first, O means outer, I means inner, and L means last. Remember that each letter represents a multiplication step. Let us follow the four arrows. First, x times x gives x squared. Second, the outer terms give 5x. Third, the inner terms give 3x. Finally, the last terms give 15. Put all four products together and simplify. Using FOIL, the first product is x squared. The outer product is 2x. The inner product is 4x. The last product is 8. Combining 2x and 4x gives 6x. So the final answer is x squared plus 6x plus 8. Special product patterns allow us to multiply certain expressions quickly without writing every individual multiplication step. We will study three important patterns: the square of a sum, the square of a difference, and the difference of squares. For the square of a sum, square the first term, add twice the product of the two terms, and then add the square of the second term. For x plus 4, the result is x squared plus 8x plus 16. The square of a difference follows a similar pattern. Square the first term, subtract twice the product, and add the square of the second term. Therefore, x minus 5 squared becomes x squared minus 10x plus 25. When two binomials have the same terms but opposite signs, we can use the difference of squares pattern. Multiply the first term squared minus the second term squared. In this example, x squared minus 36 is the answer. Factoring is the reverse process of multiplication. Instead of expanding factors to get a polynomial, we start with a polynomial and rewrite it as a product of factors. Our first step is often to look for a common factor. Both terms have 3x and the common factor. We take 3x outside the parentheses. Dividing 6x squared by 3x gives 2x, and dividing 9x by 3x gives 3. Therefore, the factored form is 3x times 2x plus 3. First, recognize that both terms are perfect squares and that they are separated by subtraction. X squared is the square of x, while 25 is the square of 5. Therefore, the factors are x plus 5 and x minus 5. To factor this trinomial, look for two numbers whose product is 12 and whose sum is 7. Those numbers are 3 and 4. Therefore, the factors are x plus 3 and x plus 4. This trinomial follows the square of a sum pattern. X squared is the first square, 25 is the second square, and 10x is twice the product of x and 5. Therefore, it factors into x plus 5 squared. Look for the difference of two perfect squares. Since 16 is 4 squared, we can use the difference of squares pattern. The factors are x plus 4 and x minus 4. Let's apply what we have learned about factoring to a real-life area problem. Suppose the area of a square is represented by x squared plus 10x plus 25. First, we factor the trinomial. We recognize that it is a perfect square trinomial. The expression factors into x plus 5 quantity squared. Since the area of a square is the square of its side length, we take the square root of the factored expression. Therefore, the side length is x plus 5. Remember, when we are given the area of a square in factored form, the factor inside the squared expression represents the length of one side. To simplify a rational algebraic expression, factor the numerator and denominator and cancel common factors. Remember that the original denominator cannot equal 0. Therefore, x cannot be 0 in this example. When multiplying rational expressions, multiply the numerators and multiply the denominators. However, it's often easier to simplify by canceling common factors before multiplying. This gives us the simplified answer of 3/2. When dividing rational expressions, keep the first expression, change division to multiplication, and flip the second fraction. Then simplify common factors. The result is 2/3. When rational expressions have the same denominator, we add or subtract their numerators and keep the denominator. Since both fractions have x as their denominator, 2 plus 3 gives 5. So the answer is 5/x. To solve a simple rational equation, we can use cross multiplication. Multiply x by 6 and 3 by 4. We get 6x equals 12. Dividing both sides by 6 gives x equals 2. To find the next term, examine the relationship between consecutive terms. Here, each term increases by 4. Therefore, we add 4 to 19 and get 23. This sequence increases by 3 each time. We can create a rule using the first term and the common difference. The resulting rule is a sub n equals 3n minus 1. We can use this rule to find any term in the sequence. The Cartesian coordinate plane consists of a horizontal x-axis and a vertical y-axis. They intersect at the origin, which is 0, 0. The plane is divided into 4 quadrants. Every point is represented using an ordered pair, x, y. To plot a point, always read the x-coordinate first and the y-coordinate second. For point A, 3 is the x-coordinate, so we move 3 units to the right. Then 2 is the y-coordinate, so we move 2 units upward.
To find the distance between 2 points, subtract the x-coordinates and y-coordinates, square the differences, add them, and take the square root. For the midpoint, average the x-coordinates and average the y-coordinates. For points A and B, the distance is 5 units, and the midpoint is 3, 3.5. Mathematics becomes easier when we understand the pattern, follow the rule, and practice solving step by step. Keep learning, keep practicing, and believe in your mathematical ability.